All right, let's talk about variation. So there are different types of variation. I know that there's a lot of definitions on here you need to write down, so feel free to slow me down as you need to. Um, Told you I like the highlighter. So we have direct, inverse, and joint variation. So let's talk about each. You'll notice that in each of these equations here, there's this variable k, and I want you to keep in mind that k represents a constant of variation, or a constant of proportionality. Um, so k is just some constant. It could be any variable, honestly. We could have chosen P for platypus, but chose k for whatever reason. Nothing to be alarmed about. Just k cannot equal 0. Something to keep in mind. So, direct variation. Notice that we have y equals k times x. This should look like an equation of what? If you're thinking an equation of a line, then you should pat yourself on the back and say that Mr. Rupnick's proud of you, because I am. This does look like our form y equals mx plus b. It does look like an equation of a line. We say y varies directly as x, or y is directly proportional to x. This language here, the way that we say this, is something that you're going to start to be more familiar with. But when we have direct variation, you're really going to have to use your eyes and look for that word to help you know which of these cases we're using. That's really going to be helpful. Then we have inverse variation. We have y equals k over x. Just in case if you didn't really get this. Right, same thing. Y varies inversely as x, or y is inversely proportional to x. The last case of variation is joint variation. And you'll notice the big difference, it's pretty obvious. This time we have more than two variables. We have y equals k times xy. So this time, y is varying jointly as x and y, joint, right? Or y is jointly proportional to x and y. So that's kind of a key thing that you'll notice. I think it should be pretty obvious when to use these. So let's practice. It says find a mathematical model for the following, or in other words, find a mathematical equation. So it says here, a varies directly as the square of r. Y varies inversely as the square of x. And the last one, for a constant temperature, the pressure P of a gas is inversely proportional to the volume of the gas. So I'll walk you through the first one and then I'll have you try the second two. Key term to pay attention to here is A varies directly. Think about how it's varying. It's varying directly as the square of R. So, if you look at the way we defined our variation on the first page, instead of being y varying directly as x, this time we're going to replace y with a, and we're going to replace x with really the square of r. So instead of being y equals k times x, instead of those variables, this time we're going to use a equals k times, and remember it's the square of r, so r squared. Okay, so that would be our mathematical model for this situation. Go ahead, pause me, and try the next two. Okay, so y varies inversely as the square of x. You'll notice that I had underlined inversely. So we have y and the square of x, very similar to our first one. So that mathematical model should look like this. Y equals k over x squared. The last one here, for a constant temperature, and notice that I highlighted that in green because the constant is temperature. So instead of using K this time, I'm going to use a T. The pressure P of a gas is inversely proportional to the volume. So if you got this one right, you should have had T equals T over P. If you didn't get them right, just think about, what you were thinking. Think about why this is really what it should be. All right, last example here. It says neglecting air resistance, The distance s an object falls varies directly as the square of the duration t of the fall. An object falls a distance of 144 feet in 3 seconds. How far will it fall in 5 seconds? And I gave you a hint. What do you need to find first? I'll actually give you another hint because I'm just that nice. This sentence right here that I'm highlighting is really going to give you the starting point to help you answer this hint. Okay, so set up an equation, understand how it's varying, and then see if you can answer the question. Really think about it. Not kidding, use your brain. Okay, let's see how you did. So remember, I gave you a hint to really pay attention to what's highlighted in purple. And notice here that I did write an equation of direct variation. The distance s an object falls varies directly, so I knew that that was direct variation. It should look like a line. Although this isn't a line because it's got the square term here, as the square of the duration t of the fall. So I started with that. Then I used the next given information because what I needed to find first was that constant, what should k be? So I used the given information. I have 144 feet equals k times 3 seconds squared. And I solved for k and I got 16. So now I really want to answer the actual question. How far will it fall in 5 seconds? So if I replace k with 16, and I know that I want to know in 5 seconds, 5 squared, we get our final answer of 400, so it falls 400 feet in 5 seconds. And yes, I did use a calligraphy pen, so that's why this looks cooler. I should do that more often. Okay, just a conclusion. Direct variation, y equals k times x. Inverse variation, y equals k over x. Joint variation, z equals kxy. Boom.